Download this code from codegive.com, link in the description below. The statement missing error in C, a comprehensive guide. The statement missing error in C can be frustrating, especially for beginners, because it's often vague and doesn't directly point to the actual problem. The compiler throws this error when it expects to find a statement, usually terminated by a semicolon, at a particular point in your code but doesn't find one. This guide will break down the causes, common scenarios, and debugging techniques to help you conquer this common hurdle. Understanding the error. At its core, C syntax relies heavily on semicolons to mark the end of executable statements. The compiler uses these semicolons to distinguish where one instruction ends and another begins. When the compiler encounters code that should be a complete statement but lacks a semicolon, or has an incorrectly placed one, it flags it with the statement missing error. Think of it like grammar. Semicolons are like periods in English. Without them, sentences run together, and the reader, compiler, can't understand the intended meaning. Common causes and scenarios. Here's a breakdown of the typical reasons why this error occurs, along with specific code examples to illustrate each point. 1. Forgetting the semicolon after a statement ***. This is the most common culprit. Any statement that executes an action should end with a semicolon. Examples include variable declaration and initialization ***. Corrected code ***. Assignment statements ***. Corrected code ***. Function calls ***. Corrected code ***. 2. Incorrect placement of semicolons in control structures ***. Control structures like if, else, for, while, and do while have specific syntax. Adding a semicolon incorrectly can disrupt the control flow and lead to this error. If statement Explanation the semicolon after if, number 5, creates an empty if block. The code block is always executed, regardless of the condition, because it's no longer part of the if statement. The compiler may report statement missing on a subsequent line, or give an unrelated error, because it misinterprets the intention. Corrected code ***. For loop ***. Explanation *** Similar to the if statement, the semicolon creates an empty loop body. The for loop iterates completely, i.e., I goes from 0 to 5, doing nothing in each iteration. Then, after the loop finishes, the code block is executed once with I having a value of 5. The compiler might complain about the missing statement inside the empty loop or something further down. Corrected code ***. While loop ***. The error is very similar to the for loop example if a semicolon is mistakenly added after the while condition. Corrected code ***. Do while loop ***. The do while loop requires a semicolon at the end of the while condition. However, forgetting it will still result in an error, although it might not be statement missing directly because the do already implies an opening statement. Corrected code ***. 3. Missing closing braces ***. Unclosed curly braces can cause the compiler to misinterpret the structure of your code. This might lead to a statement missing error at unexpected locations. Explanation *** The if block is missing a closing curly brace. The compiler expects the if block to end at some point, but it doesn't find the closing brace. As a result, it might interpret the printf, this will always print \n, statement as part of the if block, or something else entirely, and issue a statement missing error if it doesn't fit the expected syntax. Corrected code ***. 4. Problems with macros ***. If you're using macros, define, especially complex ones, errors within the macro definition can cause unpredictable errors, including statement missing. The compiler substitutes the macro text directly, and if that text is syntactically incorrect, it can manifest as a missing statement. Explanation * when print _message, hello from macro, is expanded, it becomes printf, %s\n, hello from macro, which is missing a semicolon. The compiler will flag this as a missing statement. Corrected code *. 5. Incomplete declarations or definitions ***. Sometimes, a partially written declaration or definition, example a function declaration without a body, can trigger this error. Explanation * while this code compiles, it's a declaration, it will cause a linker error at runtime, not a statement missing error. A statement missing error is less likely here, but it's possible if the compiler is very strict and the incomplete declaration disrupts its parsing. More likely errors would relate to undefined reference to add during linking. Corrected code, adding the function definition. Debugging techniques *. 1. Examine the error message carefully *. The error message usually includes a line number. However, the error might not be on that exact line. The compiler detects the error when it encounters something that doesn't fit the expected syntax after the point where the actual mistake was made. So, look at the lines around the reported line. 2. Check for missing semicolons *. Start by meticulously reviewing the lines preceding the error line. Are all statements terminated with semicolons? Pay special attention to variable declarations, assignments, function calls, and the end of do-while loops. 3. Verify control structure syntax *. Double check your if, else, for, and while statements. Ensure that there are no unintended semicolons after the conditions or loop headers. Also, make sure that all curly braces are correctly balanced, every opening brace has a corresponding closing brace. Use a good editor or IDE that can help you with brace matching. 4. Comment out sections of code *. If you're struggling to find the error, try commenting out sections of your code, starting from the most recent changes. This can help you isolate the area where the problem lies. Once you comment out a section and the error disappears, you know the problem is within that section. 5. Use an IDE or code editor with syntax highlighting and error checking *. Modern IDEs, like Visual Studio Code, Eclipse, Code Blocks, CLion, provide real-time syntax highlighting and error checking. They can often catch missing semicolons or unbalanced braces as you type, preventing the error from occurring in the first place. Make sure your editor is configured for C or C++ mode to enable these features. 6. Indentation *. Consistent and correct indentation is crucial for readability and helps you visually identify the structure of your code. If your code is poorly indented, it becomes much harder to spot missing braces or misplaced semicolons. 7. Compiler options *. Some compilers offer more verbose error messages or warnings that can help you pinpoint the problem. For example, GCC swal flag enables many useful warnings that can highlight potential issues. Example debugging walkthrough. Let's say you have the following code and the compiler gives you a statement missing error. 1. Error message *. Assume the compiler reports the error on the line printf, y equals %d\n, y. 2. Inspect surrounding lines *. Focus your attention on the lines immediately preceding the printf statement. You'll see. 3. Identify the missing semicolon *. It's clear that the assignment statement y equals x * 2 is missing a semicolon at the end. 4. Correct the code *. Add the semicolon. Key takeaways *. Asterisk the statement missing error usually boils down to a missing or misplaced semicolon. Asterisk the reported line number might not be the exact location of the error, check the surrounding lines. Asterisk pay close attention to control structures, if, else, for, while, do while, and ensure correct brace matching. Asterisk use an IDE with syntax highlighting and error checking to prevent errors proactively. Asterisk consistent indentation is crucial for code readability and debugging. By understanding the common causes and applying these debugging techniques, you can effectively diagnose and resolve statement missing errors in your C programs. Good luck.